Binomial series 1 over 1 minus x to the power k, also known as 1 minus x to the power negative k. In this video, we'll use data validation, array formula, COMBINA, and LINEST polynomial regression to generate the dataset of the binomial series and its Taylor-Maclaurin SERIESSUM expansion. And we'll compare the expansion coefficients with the regression coefficients. And we'll also show the trend lines as the value gets higher. So in this video, we'll show that the 1 over 1 minus x to the power k has an expansion, Taylor-Maclaurin series expansion of the summation of a times x to the power n, where a, the coefficient, is equal to COMBINA kn, and the values of n will range from 1 to infinity. But in this case, our n is limited to our dataset. And the value of k, we'll choose from one of these values, so it will be data validation. From the list, we'll use this range. So our k has 9 values to choose from. Then we generate the dataset of the binomial series 1 over 1 minus k, array formula, using array formula. 1 over 1 minus x to the power k, to the power k. Right now, our k is 0, so 1 over 1 minus x and to the power, that is 0. We'll chart this, insert chart, and we'll use the scatter chart. And we'll generate a trend line, which is polynomial to the degree. We'll maximize it to the highest because we have 0 to 8, so we will use 8. That's because we want 0 degree of freedom. And we show the equation as well as the goodness of fit for the curve. So if we use 8 here, the goodness of fit will be 1. It's a perfect 1. We can use 1, 2, and 3, and we can go further to 8. Next, we generate the expansion, the Taylor Maclaurin SERIESSUM expansion, which is equal to array formula SERIESSUM of the x values to the power starting from 0 incremented by 1 to infinity, and our coefficient will be this range. And we'll edit this to show the trend line as well, the trend line equation. Polynomial to the same degree 8, and show the equation. Now we'll complete the coefficients. So this is equal to array formula COMBINA kn. So k comma n. Enter. Actually, they're the same until our data set is matched until this area. But as we go farther, there's a split. just as there are split on these ends and there are split ends. But if we lower this to change this to 1, there's no split ends. They're exactly the same. But as you go higher, you start having errors here and errors here. As you go to 3, then you're gonna have few differences, slightly some errors here. Next, we calculate the coefficients b0, b1, b2, b3, b4 until b8 using LINEST and compare this with a0, a1, a2, a3, a4 to a8. So to do that, we will complete the 1 comma x matrix. In this 1 comma x matrix, there's no degree of freedom because the rows and the columns are the same. So it's a perfect square. So that is x to the power 0, x to the power 1 column, x squared, x cubed until x to the power 8. We begin with the power, which is transpose of the n values. So we have x to the 0, x1, x squared, x cubed. So this will be array formula of the x values to the power 0 to 8. So we have the x to the power 1 column, to the power 0 column, x to the power 1, which match to our x values, x squared column, x cubed column, until the x8 column. Now we can use the LINEST of the of y values and the .x. And in the expansion, we also have LINEST of the approximation y and data x. So let's compare our trend line. Say we use 4. So our B0 match to our B0 trend line. Our B1, 3.994 matches to our trend line. B2 coefficient, 9.9910. Oh, this is 10. So they are same. B3, 20.3, 20.3, they're the same. So our B0, B1 in LINEST match to our trend line. And our A0 match to our B0. Our B1 also match to our B1. Our A2 matches to our B2 values. And our A3 also match to our B3 values. This completes the use of COMBINA, LINEST polynomial regression, data validation, and array formula in generating the dataset of this binomial series 1 over 1 minus x to the power k and its Taylor-Maclaurin series expansion using SERIESSUM.